Okay, so we're going to look at the difference between a linear equation, a quadratic equation, or something that is neither of them. And we're going to look at the many different ways of being able to tell whether it's something that's linear, quadratic, or neither. Okay, so first one we're going to look at is like a table of values. We have our x and our y's, and these are essentially coordinates. Okay, so we don't have the graph to back this up. And graphing it may be helpful, but can be also tricky sometimes if you only have part of the graph. It's much easier when you can see the entire graph. So since we have these points, we're going to do something called taking first differences. And taking the first differences will tell us if something is linear. Now, in order to do this, we have to make sure we got to check our x values first to make sure that they're changing by the same amount. So if we go from one to the other, we notice that they're all increasing by the value of 1, and it's the same what they're increasing by. So we can do this thing called first differences. It's usually best if we take our first differences and we, and now this isn't, yeah, so because these values are increasing, we'll start at the bottom and work our way upwards, okay? So start with the lowest value and then come up. So we're going to take 1, and we're going to subtract the number 4. We're then going to take 4, subtract the number 9, take 9, subtract 16, and we'll take 16 and subtract 25. So this is called first differences. And if all the first differences are equal, so differences are equal, then if it's equal, then it's linear. Okay, so we'll take a look by actually carrying this out. 1 subtract 4 is negative 3. 4 subtract 5 is negative 5. So we already got something that's different here. Right? 9 subtract 16 is negative 7, and 1625 is negative 9. So this is not linear because none of these are the same. So first differences doesn't work for us. Okay. Next, what we're going to do is called second differences, and that's where you take the difference of the first differences. Same pattern. We'll start from the bottom and come up. So we'll take negative 3, subtract negative 5. Okay. We'll take negative 5, subtract negative 7. And we'll take negative 7 and subtract negative 9. Okay, and we'll figure out what these are. This is as if we're adding. So this is like negative 3 plus 5. So that'll actually give us a value of 2. This is like negative 5 plus 7. That's a value of 2. And negative 7 plus 9, that's a value of 2. So all of these are the same. Okay, and if the second differences are the same, so if they're equal, that means it's quadratic. Okay. So we kind of got to figure out what quadratic is, okay? And we'll bring up a quadratic and a linear graph after, but we'll look at the algebraic equations next. And you can technically continue this pattern. If you were to take the differences of these, now because these are all the same, you stop. But had these not been, if you take these differences, you could call it third differences, it would be a function. Now it wouldn't be linear or quadratic. In fact, they call this one cubic, and we'll talk about what these numbers here, how they build this pattern. This is what a cubic function looks like, and we won't really deal with it yet. We'll come back to that. Okay, so we take a look at this function here. Now, when we look at a function, we'll be able to tell if it is linear, quadratic, neither. We'll put that in purple. Okay. And if it's neither, there are ways of defining other functions. The ones we'll work with, we'll talk about. So a linear function, if you remember, a linear is usually y equals mx plus b. Quadratic, that's called y-intercept form, but it could be considered a standard form. Quadratic standard form is y equals ax squared plus bx plus c. And neither is anything but those, right? So anything but. So it could be a whole bunch of them. The key of these is for a linear one, the x. The x is technically to the power of 1. There's nothing there, we don't write it in, but if there's nothing there, it represents the number 1. So if anytime we have x, the highest variable's power is 1, that means we have a linear equation. If the highest variable, so this variable here, this has a power of 2, that means it's quadratic. If the highest variable, just to bring it along, to continue that pattern, because we talked about just above something called cubic, if the highest variable is y equals x cubed, okay, then that means it's a cubic function. And really you can write it like this. This might be easier. Y equals x y equals x squared, y equals x cubed. These are all different types of functions, okay? So we're just focusing on quadratic is to the power of 2, linear is to the power of 1. What power is this x to?
1.
1. So what type of function is this?
Linear?
Yeah, that's right. This would be considered a linear function because this is the power of 1. We said this one was quadratic, right? Okay, good. Our third one. Now this one, we need to be in an expanded form. So we actually have to expand everything. Have you done distributive property?
Yeah.
So we need to distribute this negative x times both of the numbers inside. So when we do that, negative x times x squared is actually going to give us negative x cubed, okay? And negative x times negative 5 will give us positive 5x. Well, what's the power of this one?
3.
3. So is it linear?
No.
No. Is it quadratic?
No.
No. Is it neither?
No.
Well, it's technically neither. It's not linear or quadratic. We do know, because now the video is not technically supposed to be about this, but we know it's technically cubic, but they don't talk about that in your class. So it's either their options are linear, quadratic, or none of the above, right? So either of these are correct answer, technically. And what we can do is we can bring up a graphing calculator just to kind of quickly see what the graphs of them will look like. Oh, that's not good. Let's go to OK. Will this open? Maybe not. Okay, maybe we'll just end it there. I'll add to it after. So let's look at our graphs. We finally got them up here. So our red graph is linear, right? And this is technically, we could put it, I'll put it to the power of 1, and you'll see it's still the exact same thing, right? Our quadratic has this almost U shape to it, right? That's what our blue one is. And then you can continuously make functions like this. This is a cubic one we quickly talked about where it makes this type of pattern, and that's the power of 3. This to the power of 4 one makes almost a, looks like a U, but eventually starts turning into like a W type shape, and then you can go 5 to the power of 6, and on and on and on. But our focus is just on the power of 1 and the power of 2. Okay?